Hey guys, Mike here with Tiny Phoenix, and today we're going to be going over a plugin for OpenAI API for Unity. So what this is just a plugin that supports all or a lot of the features that OpenAI has to offer, and additionally a couple of cool features that work well with Unity. I think this is the best plugin right now for anything related to images. If you want to use it to generate or do prototyping, anything like that. But what we're going to do today is we're going to jump in and we're going to go through absolutely every feature this guy has to offer. We think that it's at a point where it's almost complete. I think there will be a lot of additional small features or building on current features, but we're feeling like it's a good point to share. So we're going to try to run through absolutely everything that this thing does. I'm going to put hot links in the description of this video on YouTube to jump around and find all the stuff that you want to see. If you're having an issue with something or you just want to see how a specific feature works, jump down there, click around, go crazy, and let's just get started. So here I have a empty project with OpenAI imported, and let's just see like what you would do as a regular user starting out on this thing. We're going to add a empty game object and see what components we have here. So we have a couple of OpenAI components. We're going to look at AI replace text. This is the simplest one. So the first thing that anybody's going to learn when they're jumping into this is that if you want to interact with the OpenAI API, you're going to need an API key and account. You're going to see this with any other plugins out there that utilize the OpenAI API. And so what we'll do is, like, let's just go in here and see what happens if I just try to create a request without actually going and setting up that account. So let's do it. Generate text, and bam, cool. So we get prompted for we need to set up our API key before we can use this, and there's a little question mark here and here to figure out how to go set this up. So if we click here, this API key question mark, this will jump over to the OpenAI website and how to generate API keys. If you don't have an account at this point, it'll prompt you to create one, and you can log in with Google, create just an email account or any of that old jazz. To actually use it, you're going to need to set up a credit card. It is a paid service, but it is fairly reasonable on cost. So I've been working over the last 2 months on this application, and we can take a look at my billing history. I think last month, yeah, I spent $20, and I've been, hitting this thing constantly. So it's not super expensive, but there are varying costs for different models. So I'll be jumping back and forth to this API reference, but I come here all the time. If you go look at all the different models that they offer, you can hit that to see all of them, but they all come with different costs associated with them. For example, GPT-4 is a crap ton more expensive than GPT-3, and that's a lot more expensive than ADA. So a lot of information, but you don't really need to know any of this. If we just move forward, let's see, we need this API key. So again, we jump over here, we have our account set up. Let's go ahead and create a new API key and trash this guy. Just move this one. There we go. Got an API key. We can copy that. And then we just paste it in here. Notice there's an open button. When we save this, it's actually going to save to a file on our computer. So let's just say save. And then if we ever want to see that window again, you can use this OpenAI API window that pops up. And this guy has a credentials tab, which you can go to configure that whenever you want. And now if we click open, we can kind of see that file that got created in our user folder. So bam, right there. But yeah, it looks like our API key now is set up, and we can click generate. Cool, this sentence is used to determine if a person yada yada yada. So we got, this is a response from OpenAI API. If we go to the console, we can kind of see what our request was. Request sent. We can see this whole request body. So this is just a HTTP request in the background, technical, but it doesn't really matter. And we can see exactly what was sent. We asked for this model, text DaVinci 03, which corresponds to GPT-3. We sent this prompt, ends equal to 1. We can talk about that later. Max tokens, temperature, we can talk about all that later. Let's see what happens for right now if we don't check stream. And let's try a different model, ADA. So all the way back to the bottom, here's our next request that was sent. We can see the model was used was ADA this time, and we did not stream, and you see that it just popped in here. Again, if we click stream, we're going to get it token for token. which can be a little bit more responsive, but yeah. Sometimes a little bit harder to handle in your code, but this handles a lot of it for you. Cool. Let's jump next over to raw requests. Raw requests are really cool. What this is just when you're getting started out and you just want to know, like, hey, this is cool what your components do, but I want to make my own. What do I do? So right here we have three main request types. These are the request types that OpenAI API uses right now. So one of them is AI text, one of them is AI chat, and AI image. They differ a little bit, but basically all of the different models that are available use one of these three. And if we want to see like what those look like, we can expand this AI text request. And then here we have a model option. So these are all the models that use AI text, a prompt, and N is the number of responses that you want back. So if we set 2, we'll get 2 responses back from the AI. Max tokens is going to be the total number of tokens used up by the text prompt request here, and the response that comes back from the AI. So if this is about 50 tokens, and tokens are kind of just like words, if this is about 50 words, then we can get back a maximum of 350, or we'll end up hitting our max token limit. This is different and can be higher based on the model that you're using. Some models have really high limits, like GPT-4 has about 8,000 token limit. GPT-3 has I believe, 2,000 token limit. Temperature is cool. Temperature is basically how much risk the model is going to take in its response. Risk is basically the word that OpenAI uses to describe it. And what this really just means is if we set temperature to 0, that's basically just going to make this model deterministic and always return the same exact thing. And it's not going to be very risky. It's going to be a very safe response. And then 2 is going to be like wiling out crazy, weird responses and very different. But let's leave it at 0.8. This is the default from OpenAI. And then we can actually see, as we change these things, we can see the text over here actually updating. And this is the script that you'd actually call in your script file, any C# file, to actually get the same result that we're going to see over here on the left. But let's execute here first and see what we get. Then if we expand AI text, this is going to be the response back. Cool. So we have 2 options here. We got a woodchuck, also known as a groundhog, can chuck up to 700 pounds of wood in a day. And then here we get a response between 35 and 70 cubic feet of wood per day. So notice these are a little bit different and maybe take a little bit of risk because we've been this 0.8. And we got 2 responses for our n is equal to 2, and we're within our token limit. So if this token limit would have got hit, we'd see finish reason max tokens. But yeah, so kind of cool. Let's jump next to AI chat. So AI chat is very similar, except for it has messages instead of a single prompt. So what this is mainly used for is if you want to have a back and forth conversation with the AI, or have your users have a back and forth conversation, you can take the response, append it to the message you're going to send in your next request. So we can just actually then simulate that here. So here we have how much wood could a woodchuck chuck, same exact thing. Get our stream response, look at our result, and here we go. We have a similar result here. A woodchuck groundhog does not actually chuck wood, as the saying is a tongue twister, yada yada yada. So kind of interesting. We got some feedback. Expand that again. It's kind of being a little funky. Cool. Let's see our second message. A study by wildlife biologist Richard Thomas found that a woodchuck, also known as a groundhog, can chuck approximately 700 pounds of dirt. So a little bit different, but like we could take one of these and say the user was having a conversation. Let's just reduce this to 1. Let's come back up here, add another message, and if you're scripting, you just append this to your array of messages, and we'll say the assistant came back with this response, and then the user is going to ask another question. Are you sure this is correct? And let's send this request. And now that we've got a whole conversation going, the AI can basically look back and call back to previous things that were said and respond in a more logical manner. Okay, cool. So here's our results. Yes, I am sure this is correct. Woodchucks, also known as groundhogs. So first of all, they're answering the question, and then they're calling back to previous information. So this is a super useful format. It's the newer format released by OpenAI, and it also has, it's used by the newer models, so GPT-4 and GPT 3.5 Turbo Plus, basically. All right, cool. And then again, like that whole conversation, if you wanted to write that as a script, like here's exactly how you would do that over here on the right. You could just copy paste this straight into your code and it would work. Next, AI image. So this is like one of the coolest. We can just ask for an image of a woodchuck. We can set the size. 256 is the smallest, and 2x that, and 4x that for large. And then we'll get some response back. So let's go ahead and do it. Cool, there's our response. The URL is just where OpenAI API stores the images initially. So nice little features that we crawl those URLs and then just download the image and save it as texture 2D. Also cool, not a very good woodchuck. Let's try it again. Let's do a bigger one, but leave it on woodchuck and generate one more. If you're wondering where any of these images went, if you go to the project folder and just click this, you'll be able to see it's stored in generated images temp. And there's our next woodchuck coming through. Hey, that's a fine woodchuck. All right, awesome. Cool, so that is the raw request for you. So this can be used, to send requests or do whatever you like. If you'd like to interface with this or use it as an example to see how it calls scripts, or just use it as like, okay, I need to send this request. I'm going to go in here and make sure that I set my temperature to what I want and see that, oh, okay, that's how you set the temperature with the temperature tag. Or if I change this to GPT 3.5 Turbo, how do I do that with script? Models chat GPT 3.5 Turbo. So it does a little bit of the heavy lifting with the initial learning for you, and I hope it's useful. Cool. Let's jump next to text completion. So most of these are actually just components that can be attached to game objects. So this is the one we were looking at earlier, and it just can run in this little OpenAI window for ease. So cool. Let's move to image generation. So image generation, pretty sweet. Also comes with some extended features. For example, OpenAI returns all of its images with backgrounds. It does a cool remove background feature and wrap texture feature, which is also pretty handy. But let's just actually use this one in the scene because it's a lot more fun. Cool. Let's go to our scene again, and this time, let's see. Yeah, let's make an image sprite. Just create empty here. Add a sprite renderer. And give this guy an image of anything. Cool, we got our image. And let's say you just wanted to change this image to something else in your game. You could do that with the OpenAI image replacer. So we say again, OpenAI here, and replace image. Okay, so this is, again, this component we were just looking at a second ago in the OpenAI window. And let's just give this a prompt. Let's call it pixel art avatar for a game. Cool, and we'll keep this small. And if we don't check replace in scene, it's not going to make any edits to our sprite renderer quite yet. So let's just see what it generates and make sure we actually want to use it. Cool, there's our image, and yeah, sure, that looks good to me. So let's go ahead and check replace in scene, and bam, we got our image in the scene. We could obviously do whatever we want with this. If we want to make it a little smaller, whatever. But a cool feature, again, like I mentioned, is removing the background. So we can check remove background here. And what this does is it tries to grab 4 sample points from around the corners and Then it throws out an outlier and uses the most similar 3. And you can see it wasn't perfect, kind of got rid of some of our hair. And that's just because this default color sensitivity, we can drop that down a little bit. And that looks pretty good, but we still have this like bottom area that's kind of annoying. So what we can do to get rid of more colors is we can actually just drop down these sample points and we can add a new one. And then we can change this color, it just defaults to super ugly pink. And then this also, you know, you can make this real big if you need to. And wherever you suck up, it will drop a new sample point. And let's do another. And let's try to get rid of this black line. Oops, I got rid of one. Let's try to get rid of this black line as well. Cool, a little bit tougher to get rid of that black line, but not bad. We can also utilize some of this feather size and feather amount to try to get rid of artifacts left in our image. So if you notice, this basically just adjusts like how far you feather in, and then feather amount is just like how hard that cutoff is. So that's pretty close. We still have a little bit down here. We can add another sample point. I do think that most of the time I don't have to add this many sample points. Let's try that again. There we go. That's pretty good. We still cut out some of his face right here. Maybe we just adjust color sensitivity down even a little more. Yeah, still not great, but not bad. Let's try to generate another one. Let's see what we get. Hey, so this one's going to play a lot nicer. So notice I didn't have to do anything to remove this one's background. That's pretty typical. But you can always dump into Photoshop and do what you need to do if you have Photoshop skills. I don't, so I do a lot of this point sampling, finicky playness. But yeah, so let's go ahead and see what this looks like with the background. Pretty simple, just white background. We'll go ahead and do one more just for fun. Cool, so this one we probably could adjust a little bit. We got some white lines here and here and here. Let's go ahead and up the color sensitivity on this one. And that's pretty dang clean looking, I'd say. Sweet, so there's our avatar image. Now, that's pretty cool. What if we wanted to create like a texture? So let's go ahead and just name this guy. Let's say we want to create a textured repeating background for our avatar or something like that. Let's see how you do that. Okay, Coolio. Here's our avatar. Let's go ahead and this time say pixelated sky with clouds. Let's see what we get. And we do not want to remove our background anymore. Hey, that is kind of interesting. Let's go with it and see what we can do. Okay, so this one just being a sprite, it's kind of annoying to repeat sprites, but we could make a texture that we repeat. And that could be a better way to do this. So let's try that. Let's see what happens, or what we would do in that scenario. So we do want to wrap this, and we'll go over how that works. But first, let's switch this over from being a sprite. Let's go ahead and remove this. You'll notice that here we're going to lose our reference to our sprite. That's fine. It will play nice with that still. Let's add a mesh renderer. And let's set this to, actually let's see, what do we have on a regular default old plane, 3D plane? Okay, we use a mesh plane with a plane filter, so let's go ahead and do that. Filter. this to be a plane. Cool. Now we're just going to update this. Let's just use a, doesn't really matter what kind of material we use, but let's just create one for fun. And we'll just leave this how it is, standard shader. Drop this on our new material. And now let's say we want this image to be, you know, tiled across this guy. So let's go ahead and select this mesh. And all we'll need to do is update anything about this texture, any settings, and it will replace it. Cool. So notice that it's trying to show an example of how it looks wrapped over here on the right, but we still don't have this wrapping, so let's go to our material, or even on here we can just scroll down, rename this avatar background. Cool. Let's expand this guy out, and now let's just set some tiling on it. So let's say tile 4x4. Excuse me. Cool, and this does not look great. You can still kind of see some bleeding into the edges, and it doesn't really line up perfectly, so let's play around with the settings on it. So basically you have two settings. You got just this preview grid, just lets you see what it looks like at different tilings, and then we got this wrap size. So this is literally just going to push the texture into itself to make it repeat. And we can kind of just play with that until it looks pretty solid and lines up pretty good. That's not bad. Let's see what happens when we go in all the way. That's pretty good. We'll just keep it like that. And there's our avatar with some repeating random background. And again, like, we could just regenerate these all we wanted. Let's try to do another one and update it. And now if I wanted to just generate and see if I could come up with a new one, I could just uncheck replace in scene. Like if I liked this one, but I wanted to see if I could generate a better one, uncheck replace in scene, and I could just sit here and generate all day until I find something better. Then check replace in scene again, and replace it. That one's actually kind of cool. I like this. Let's replace that. Oh, this one's super cool. Cool, so I think that gives you an okay idea, like some of the things you can do here. What do we got next? Let's go back to OpenAI and see what else we got. Okay, so that was image generation. Note that replace in scene is not supported here inside of the editor window because it's not part of the scene. What do we got next? We got scripts. Cool, so scripts is just a beta feature we've been working on. What this does is just allows you to generate components. I'm working right now on generating other types of files as well, but components is pretty interesting and doesn't work too bad. So like, let's see like what we can actually do with our current scene. So back to our avatar, and let's update this so it's not so far away. All right. Okay, cool. So now let's just say we want to move this around or do something with it when you press some keys or something like that. Anything you could think of, really. Let's click our avatar, super realistic example, and let's just say add component, OpenAI component, and let's type what we want this script to do. So let's say we say move the game object along what axes are we on here? I'm going to just move it along the green and red axes, so XY. Cool. Move object along XY axes when pressing W, A, S, and B. And then let's just start with that and see what we get. We have a lot of advanced options in here as well, but let's just start with the basics here. Cool, so it looks like it worked, and it's going to try to save this out to our generated code section and give it a name. You can change this name, call it whatever you want. We got XY axis movement controller, and we'll just say save. Coolio. And now if we want to see like anything about that, we can go look at it. Here's our script in the beautiful Unity script viewer. So we have a serialized field for speed, for height. We got some nice controls on it, some tooltips, and in the update function, looks like it's compiling that script, just noticed it. In the update function, looks like we're doing what appears to be moving up and down and left and right based on those key presses. So we can just see if it works. So it looks like here speed's set to 5. Height, I don't really know what height is supposed to be in this scenario. Let's click on that again. Height, how is height used? Who knows? Let's just run it. All right, game, run. This is the definition of a live demo. All right, cool. I press left and right on my keyboard, and look at that, sweet. So it actually does work, and we can make edits to this guy as well. So you could edit it right here on the component, or you can edit it in the OpenAI view, however you want to do it. Let's stop this. Go back to our avatar, and let's say we wanted to spawn a new one of these whenever you press space or something like that. Let's try it. So actually this prompt no longer has any meaning. If we wanted to create a new one, we could delete this script reference here and start from scratch, but you notice anything that I type into here now is going to go away, not be saved. Now we're in edits mode, so we can type any edits we'd like to make here. So let's do that. Update to spawn a new instance of this, let's say of the game object added via the inspector when the user presses space. Cool, and let's go ahead and look at our update. Still going. There we go, there's our space update. It also doesn't look great to update this in the component right now. Definitely works, but it's a lot easier to update via the OpenAI window. But let's go ahead and give this a go. You can also see our edits here in the code before and after. If you make a mistake or anything like that, you're able to go grab it. We can see what updates we asked it for. Cool. Let's go ahead and run this and see if we can spawn something. Oh, look at that. It's creating, all of them now are creating another one when I press space. So I'm about to crash Unity and probably my audio stream. It also is placing them at just with a Y offset and not an X. So let's try to make one more edit. And this time let's do it through the OpenAI window. So here again, I can delete this and reference any other monoscript to update it. So let's grab that other one we created. So it was like XY axis movement. Okay, cool. So there's our script. Let's go ahead and add another edit to this guy. So what do we want to do? We want when the user presses space, or when we instantiate a new game object. Oh, height is where it gets placed. but it's using height for the Y. I don't know, weird. Let's say remove the height setting, and let's just see if it can deal with that. Also, I spelled setting wrong, so let's see if it could deal with that. Cool, updated. No more height setting. Let's just see what it ended up doing now that there's no height. It looks like transform position X and Z. It looks like it's just spawning it right on top of ours. So let's give it another edit. Let's say when instantiating a game object, make the X, Y position a random value between -10 and 10. Cool, there's our new random range, and that actually looks good. So let's see what happens. Space, space. Yeah, and now they're all creating more again. Madness. All right, cool. So, I mean, I think that's a pretty decent overview. You can literally think of anything that you want and type it into this thing, and it'll try to create components for you. I definitely want to do more with it, but I don't advise anybody use it in production. It's really just for fun. Yeah, I think that's just about it. If anybody has questions about anything, we have a Discord channel. You can jump into our Discord, Tiny Phoenix Discord channel. It's on the Unity page, and it'll be here in the Unity, in the YouTube description as well. But yeah, thanks for sticking around and checking this out, and I hope it was useful. If you guys want me to cover anything else, just hit me up. Thanks.